Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Husna binti Muhammad Nizan. My group members are Muhammad Nizam bin Indrawati and Nik Akmal Aizat bin Nik Zamri. We will present about Lab 3, which is AC high voltage measurement and monitoring. Introduction. In this experimental task, we will be exposed on the application on the Kit Control 4.0 High Voltage Construction Kit, which is the latest technology from Hifli Hippotronics, Switzerland. We will be experienced using Picoscope 3000 series for displaying the signal of AC high voltage. The Picoscope 3000 series PC oscilloscopes are small, light and portable, while offering the high-performance specifications required by engineers in the lab or on the move. These oscilloscopes for analog channel. The flexible high-resolution display options enable we to view and analyze each signal in fine details. Operating together with the Picoscope 6 software, this device offers an ideal, cost-effective package for many applications, including embedded system design, research, test, education, service, and repair.
Construction of parallel AC high voltage measurement using FC and picoscope. As you can see on the figure, this is connection between frequency converter and picoscope. The connection from secondary unit to VM1 is to measure the voltage, which is the maximum voltage of 7 volt RMS. Select the channel that has been connected to the picoscope and make sure the channel is activated. When the channel is activated, select AC for the compiling. Select the range that we need to measure for peak to peak. Then inside the divider ratio as the secondary unit voltage slash division, the offset make sure at 0. At the data log, we need to select channel A and select AC because we want to measure AC. Last step, after completing the step, we hit the reset button to reset system that we had been organized. This is the schematic circuit of the frequency converter and picoscope. As you can see, the power supply is 100 VRMS and 50 Hz. It's connected to two capacitor that is 100 picofarad for high voltage level and 2 microfarad for low voltage level. Then it's connected to a coaxial cable into the VM1 of the frequency converter and VM1 for the picoscope. For suggestion, the safety regulation that needed to be concerned at the earthing switch and clean testing layout, the earthing or break copper need to be tied properly to the frequency converter, floor pedestal and secondary capacitor so that it can damage the equipment if the earthing connection is not tied properly. Secondly, we need to check the earthing with connection rod that is provided at the lab. We also need to double check on earthing switch that must be properly touched at the top of the electrode. Next, we also need to make sure to make a clean setup on the wire that is assembly to prevent hazards.
For section 2, which is configuring the procedure of setting the kit control in picoscope. Source control. The function of the source control is to increase the percentage of the graph and to increase the gain in the system. Primary sites of transformer progress. Show source voltage. Show source current. Show background noise. And VM1 and VM2 are for AC. Then, system monitoring of secondary side of the transformer with 8 slots. The point at the frequency converter related to the slot in the system monitoring. Then lastly, which is alarm system. Alarm system indicates red color means we are not able to do any injection. It shows condition when problem exists and we need to press the red button which is reset. For customer setup, The serial number and the voltage divider ratio multiplier for the secondary unit must be checked and must be confirmed in the manual book, so that we will ensure that we use the right apparatus. Then the serial number is 223411076-04, while the voltage divider ratio is 19651.1. The voltage divider ratio must be set in the customer setup. For the picoscope setup, function of the important section in picoscope 3000 series are firstly, acquisition sample. This is to show the number of sampling for 100k dot sample in the graph. The higher the sampling point, the better the shape of the graph. 100k is very suitable for the measuring and monitoring. Next, interval. This shows the accuracy of measurement. The sampling interval is taken from 2 points in the graph obtained. In this case, it is from 5 microfarad to 15 microfarad. Next, trigger setting. This is to trigger the impulse generator, capture signal, and assume threshold level. Next is activate channel, which is to activate channel A, channel B, channel C, and channel D of the picoscope. Then determining the coupling for the AC signal and set the divider ratio. After that, there are AC tab, which has function for the value of RMS, RMC, and peak value. There are also button for frequency setting and total harmonic distortion. Lastly, activate channel button and reset button before running.
Assalamualaikum, my name is Muhammad Nizam bin Drawati and I will present for section 3, comparison for analyzing the reference signal from kit control and display signal from picoscope. And as you can see here, this is the table, and from the left here, output voltage in percentage, reference in kilovolt RMS, display in kilovolt RMS, error in percentage, and frequency in hertz. And the output voltage starting from 4.3 to 10, 13, 17, 20.5, 21.5, 26.5, 33, 38.7, 48.7, 58.7, 68.7, and lastly 0. And the error percentage is the result from the calculation between reference and display, and the frequency used is 50 Hz. Okay, since we only use VM1 in this experiment, we only need to construct the comparison between reference, kit control, and display picoscope for VRMS. As shown in table comparison, the percentage of error decreases when the output voltage increase. This shows that less error occurs when the output voltage at high level. The percentage of error can be effect due to sensitivity, range of scope, and coupling setting. According to the picoscope 3000 series specification, the input sensitivity is 10 mV per division to 4 volt per division, 10 vertical division. For coupling setting, this experiment used AC coupling to obtain the result. AC coupling only allows only AC signal to pass through a connection. It removes the DC offset by making use of DC blocking capacitor in series with the signal. And for the conclusion, in this experiment, we are able to construct the parallel AC high voltage measurement by using kit control 4.0 and picoscope 3000 series. In this part, we are able to properly draw the drawing of schematic circuit by considering the inner circuit, contact, and conductor. Secondly, able to familiarize the procedure for setting the kit control 4.0 and picoscope 3000 series. In this part, we are able to present clearly the feature and the function of kit control 4.0 sections, which are source control, primary side of the transformer progress, scope for primary including voltage and current, system monitoring of secondary side of the voltage of the transformer with X slot, and alarm system. Finally, we are able to construct the table of comparison between the result of reference, key control, and display picoscope. In this part, we calculate the percentage of error between those values and discuss about discrepancy between reference and display based on calibration fact. That's all from us. Thank you.